This is the recording for our lecture in 301. It is the 7th, and what we're going to cover is the intro to Inventor. But I put on a little video I made. I noticed that was the main problem from last week, is the annotations on large objects. Everybody got the one-to-one stuff done very easily, but getting those annotations for the large objects was difficult. So I've made a specific video for annotating large objects, and it's in the week 5 playlist, and you've got it here. And it's about 5 minutes long, 4 minutes long, and I think that will help. And now I want to do the intro to Inventor for mechanical parts. And this, this is just part of that whole, this is intro to computer-aided drafting and design. And yes, we've focused on AutoCAD, but we do want to show the breadth that is available that you might become adept at depending on what your focus is. And if you're doing mechanical design or weldments or flat plate layouts or anything that you're building from steel or things, even wood, but mechanical parts mostly, Inventor is good. Now, I've done some cabinetry work in Inventor. I've done large framework in Inventor. But our favorite one was for a group of students who sent some equipment through NASA up on a weather balloon to about an elevation, I think they went 8 miles high. So this weather balloon it went as high as it could go where there was any atmosphere, period, to go to. And it was taking data about something, gamma rays, blah, blah, blah. It was something for our physics department, and the students put it together. But then the thing just basically came crashing down, and it had to withstand a 4G crash landing. And so that's kind of cool. And they made the box and did all the design and everything in Inventor so that we could model that crash landing for the parts. So that was really cool. That was an actual thing that we did in it. And it was just a box. You go, you made a box? Yeah, we made a box, and boy, was that box something. It took us about 8 weeks to design the box and about another 8 weeks to make the prototypes. So it's mostly for mechanical parts. Yes. Yes, it's got a very, very good finite element analysis package. Now, we've got just the basic one, but you can do flow packages and crash packages and impact packages. You can shoot it with a bullet and see what happens. So there's tons of packages that are available. We have the static finite element analysis, and we have a dynamic one that we didn't bother to use. We just estimated what the forces, we did a little calculus to find out what the forces would be on it and applied those forces in a static version to make sure that it was fully strong enough. So here we go. Here we are on VMware, and I'm going to do this part, and I'm going to do it in Inventor. Now, Inventor is interesting. It's got a 3D thing, and you'll see the view cube is common as what we always see. And then there's a sort of what you've got in the model. And what it does is that it each little part of the model you make, it takes care of. Now what I'm here is I'm in a part model. Okay. When you make a bunch of parts, you put them together into an assembly or a weldment model. So this is a part of, it's like a standalone thing that you would make. Okay, so it's made much like in AutoCAD. You start with a sketch. So I'm going to look at it, and I'm going to try to make this Z thing. And then I'm going to take away this kind of funny little shape here. And then I'm going to add these two shapes if I can. And I notice that it's even about the center line. So that's kind of what I'm going to do. I'm going to make it on the center line. I'm going to start a sketch. And I'm going to have this uppy down part. And I see that there's something that goes over 2. And the wheel is backwards, by the way. So I always get it wrong. Down 0.4. And then it's just like I drew before. I'm going to come down 1.85. Then over 1.75. Up 0.4. You can do the offset. I can offset. That's going to offset the whole thing. So I can draw over 0.4 and come up. And then over 0.4. And then I can trim away this little part. And I think I got that right. Let's just see. I'm going to put an overall dimension from here to here, 3.75. So that's correct. Now here's what's, I'm going to show you something really cool here in a minute. There we go. That's my thing. And now I'll extrude it, and I'm going to go each direction 1 inch. So I'm going to extrude that thing, and I'm going to go each direction to a total of 2. There. I got the major part. Now here's what's really cool. Those parameters are all in here. And if I want to, I can change something. You know, if I found that these were not the right length, I can change it using my parameters. Yes. The benefit is when I create this and when I create this, I can make that shape and go both ways also, that rather than trying to find a plane that it's on. Yep. And that's a personal preference. And as you, oops. So there we go. So yeah, that's going to be a little bit easier for me. Now, I don't have to do it that way, but I can. And it could be that I want to do it a different way. But now let me go to this top thing and do this little thing up here. So now I'm going to start a sketch. Oh, and by the way, over here, you can see that extrusion. And I can go change the extrusion. Or if I open this up, I can look at just the sketch and I can change it. So that's one of the nice things is it helps me keep my little pieces of what I did straight. So now I'm going to go on this top piece and I'm going to come down. I'm going to 0.6, 0.4. Okay, so just like I did before, 0.6, then over 0.4, down 0.2, and over 0.8. And I can do the same thing on the other side, or I could mirror it. But I think I'll do the same thing. 0.6, 0.4, 0.2. And I'm going to show you why I did that. So I think that's all correct. Now this is cool. When I extrude it, I can go the other way and I can just go through the part. So now as I change my other parts later on, it will always go through the part. So I'm thinking this thing through. That was done as my distance is through all. So I could go to a fixed distance or to an object or to next, or I could just do a fixed distance. This lets me pick the direction, doubles, asymmetric. I can do a taper on it if I wanted to, but there isn't one. Kind of cool. And this says to subtract it. So now, if I want to get back to that plane I was working on for my next piece, I can go to there and I can just draw. So there's a line. Now I want to draw at an angle of, I'm going to say 135, I think, to make my 45 degree. There it is. It goes, and you'll see there's a little symbol there. It's going to that line, and that's called a constraint. So if that line changes later on, it'll be there. And then I can just connect those two. So now I've got a new shape. And now you can see that when I do my extrude both ways of 0.4, it really is right. Oh, except I clicked out of it before I did it. Both ways. Total of 0.4, bump, bump, bump. There we go. And now I'll do the same thing on the other one. I'll find that plane. And now I can't really see it, but I can catch it. Or I can change my view to be wireframe. That might be easier. So there's a view bar. Now let me get back to my sketch. So I'm going to go from this point, and now I've found that point. Now I can draw down to that point, and I can connect those. And I'll go back to my view because I like working shaded. Okay, so now I can extrude again, both directions, 0.4. Got it. Isn't that cool? I've got my part. My part was done with four extrusions. Okay, so I went to my view, and I chose wireframes so that I could see it. Okay, so, and sometimes it doesn't hit the snaps very well. But in this case, everything's really straight and it was on the line so I could find it. Okay, so there we go. So I've got my part. So now I save the part. File, save as, and so I'll call this one bracket, right? Now, one thing I didn't do was make sure that I'm in inches. But I think I am. I have to remember where to go to do that. But I'm pretty sure. I think that's in manage. Oh man, it's somewhere up in here or in here. Options. There it is. The units are in here somewhere. Boy, now I'll have to go find those to make sure to show you where to set units. I'm always having to look around for those. But I can check here. They're in inches. So that's good. So I know that they're in inches. So now I want a drawing of it. Inventor is a little bit different. There's parts, there's assemblies, and then there are drawings. So I'm going to come up and make a new. And I'm going to come down here and I'm going to make a drawing. Actually, I'm going to do it a little different. I'm going to do it a little bit differently than that. I can do that, or I can right click on my bracket and just go directly to it. Create a drawing view. I'll make it English. And I can say, I want to start with my right-hand view. I'll make it 1-to-1. But look, this thing is huge. Huge. So I need to right-click on my sheet, edit, and what is that? That's an A-size sheet. There we go. And I'll notice that my ANSI little thing here is a little bit large. So I'll delete that one and go to my title blocks and find a regular one. There we go. Now this view I can just drag. And this is like, do you recognize this? Huh, isn't that cool? Now you're going to really love this. See how it clicks right into place? That's so awesome. Let's see, I can move this down a little bit. I can move this up a little bit to give me more room. See, I can just pick that line, or I can pick between two spots, and see how it clicks it into place. I love that. Oh, want dimension. Now here I have to right click and tell it I want horizontal. I'm going to take that view again and move it just a hair more. Oh, you know what? Look at this. I forgot to put my chamfers on it. Ah, well, that's okay. I'll come back to my bracket and I'll put the chamfer on it. where a chamfer 0.4 even on each side. Oh, isn't that better? Is that the coolest thing? These things truly are attached to each other. And what's awesome is I can actually give it a proper chamfer call out. Let's see if I can. Come on, why isn't that giving me my chamfer? Must be too close for it. No, it'll do a chamfer. I don't know why that's not giving me my chamfer call out. Huh. That's interesting. Could be that it's just too close and won't fit. But we can do that again. And then things line up. That's interesting. And the overall needs to go on there. Yep, it's chain. They have tons of different ones. You can also do ordinates and baseline that you can't really do. You can do some arranged dimensions that helps out if you want. It's kind of cool. What I mean, there's a lot of extra stuff on here. So there you go. That's how you do it. Now, to get this stuff edited is a little bit weird. You have to actually click the A in this field text, go to a blank one, and click this little button up here. So that's a little bit weird, where you can start putting stuff in. Bracket. Company is American. And you can make templates of these and all sorts of stuff. Here's about your project, part number, stock number, description, revision number A. I mean, it's much the same. This is all exportable very easily, whereas in AutoCAD, you have to do that export button. So, kind of cool though, huh? Isn't that nice how that works? Now, here's some more cool things about this. I can take this thing and give it a material easier than I can in, let me make it ductile iron as an example. Or I'll make it a phenolic resin or something like that. And what's neat is that when you do that and you look at its properties, let's see if I can find. Now I have to go back and find stuff. Where are this thing's properties? There's its physical properties. So I can update it, and right off the bat it gives me, and I can set how close I want to do things. Very quickly it gives me all of these, and that goes into my finite element analysis. It also makes it cool if I want to render it. Okay, and I don't render it here, I render it in a different view. Although there is some presentation work that you can do here. Okay, but you can assign that material. And then when you do your stress analysis, this is kind of cool. I'm just showing it because it's really fun. Okay, let's say this thing is going to be, it's phenolic resin, and so I'm not overriding it, so that's cool. I can fix a portion of it. So let's say that it's fixed down there, and that there's some sort of piece that's going to kind of work on this thing a little bit. So I can put maybe a pressure, because there's something going to be in there. I can put a pressure on the top of maybe 20 pounds per square inch, and I can put a moment maybe on that of 15 inch-pounds. So there's a weight and there's something trying to twist it. So now I can do a simulation of it, and it'll tell me. Isn't that cool? So, and it shows how it's gonna, that thing's gonna go, ah! Now it doesn't really go that far. This is only 2,000 PSI on it. And if I look at my displacement, it's only a 64th of an inch. So this is just showing you how it's going to react, and its values are bigger. And you'll see that it's got a safety factor of 2.69 at the minimum. Isn't that cool? Yeah. Yep. So let's assign it now an override. And yep. So now let's say it's a polypropylene. Is that something you use? Maybe. Okay. Well, the phenolic resin is fairly stiff, but it'll be okay. But let's say that you want to make it out of a PET plastic because you want to 3D print it. Okay. And so now let's rerun the simulation, and everything, the stresses are the same. But let's look at, it's just about the same, 2.84 instead of 2.69. So yeah, so it's kind of good. And the displacements are much less. The PET was much, look at that, 4 thousandths of an inch displacement. So that's kind of cool. So yes, this gives you all sorts of things that you can work with, and kind of fun. And you can put pressures and forces and moments. What's this Apple gravity? You can place gravity on it. You can assign different materials. You can go to your parameter table and change different parameters and do different studies. There's another thing in here that you can do, which is really cool, which is a shape generator, which based on that, it'll allow you to take stuff out. If you want, you can preserve certain regions, say that has to be there, but maybe it'll change this to be much smaller. So there's all sorts of stuff which is not part of Design 301. This isn't part of Design 301 either, but the idea that you can do these pieces, make parameters, and then do an analysis is a really, really cool thing. Yeah, so that's Design 328, where you'll learn, and you'll learn more than just that. That's that's a portion of the class, but it'll be interesting to you. Okay, any other questions on Inventor? Let me go over it again. There's a part that you make, okay, and then there's a drawing that you make from the part. Okay, the part has a template that if you right click on it, you can edit it and change it and do different stuff. And it's got a title block that you can use. And to fill in the title block, you double click on the little A, find a blank space, and go to those. It's not very well done, tell you the truth. Most of it's usually templated for you. Okay, and then you can put in your views. Back on the part, oops. Back on the part, you really make a sketch that you see here, and then you extrude it. It's sketch and extrude. It's that way. It's much like AutoCAD, SolidWorks, Fusion, and SketchUp. They all work that same way. You make a sketch and then you extrude it. But when you extrude it, you can extrude it as cut away the stuff, or extrude it where you're adding material. There's other ways too, intersect, and you can actually make it a new solid. So then it's just working with it. You can add chamfers, you can add holes, you can do all sorts of cool things. And then up on the materials, you can tell it what you want it to be made out of. And that sets its properties for when you go and do cool stuff. So there we go. That's your intro to Inventor. Okay, so yeah. Yes, you can do that, and then you can save this, and I can show you how to do that. There are some presets that you can go to, and then you can change them. So that's cool. Okay, so I'm gonna stop doing this.